Most of us are stuck in a basic AI loop.
Yeah, that endless hamster wheel.
Exactly. You write a prompt, you get a bad result, and you just keep tweaking that same prompt.
This is so frustrating and notoriously slow.
But there is a much more powerful way. Beat. Welcome to our deep dive for today. We are unpacking a workflow from Maestro's DIA. They use Claude Code and a tool called Ultracode. The mission here is running multiple AI agents all at once.
Yeah, this workflow completely flips the standard script. We are moving way beyond basic prompt engineering today.
Right.
We're going to cover the foundational harness structure first. We'll look at these intense verification loops, and then we'll see true parallel processing in action.
To break out of that simple prompt cycle, things must change. We have to change the environment the AI operates in.
You can't just keep throwing tasks into a blank chat box.
Right. Which brings us to a concept called the harness. Let's clearly define that technical term right now. A harness is a setup of rules and tools guiding an AI's specific job.
That is a highly accurate way to frame it. You are giving the agent a very restricted workspace. You remove the chaos of an open-ended conversation completely.
It is like hiring a brand new employee. You don't just yell a task at them in the hallway.
Right, you'd never do that.
You give them a full onboarding packet. You give them a dedicated desk and resources. Aaron Levy actually highlights this exact concept.
Oh, yeah.
He says an agent harness is crucial for complex work.
Right. And without that structure, agents just get completely lost. They desperately need those rigid boundaries. Otherwise, the AI tries to be the researcher, writer, and editor simultaneously.
I still wrestle with prompt drift myself.
Yeah.
2-sec silence. I often start with a very clear goal. The AI gives me a decent draft, but I want one small change.
I know where this is going.
I ask it to adjust one specific paragraph. It fixes it, but somehow ruins all the formatting.
Exactly.
After 3 prompts, it has forgotten my very first instruction entirely. Breaking instructions into smaller harness skills fixes this.
And that focused environment leads right into the verification loop. The workflow does not just blindly accept the first answer.
Right.
Standard AI outputs text and just assumes it's finished. But this system adds a mandatory quality control checkpoint. Adi Osmani calls this loop engineering.
Okay, loop engineering.
Yeah. Outputs are scored against very strict criteria. If the score is too low, the task simply runs again.
So it actively refuses to move forward with bad data.
Precisely. It keeps looping back until it passes the test.
But wait, how does the workflow prevent an endless loop if the output keeps failing?
It relies on highly specific checking criteria to eventually force a pass. The rubric asks binary yes or no questions to break the cycle.
So strict grading rubrics force the agent to eventually hit the required target.
Exactly. It creates a mathematically guaranteed baseline of quality.
But this verification loop is only effective under certain conditions. The automated grader cannot be biased by the worker's messy process.
This is exactly why fresh context is so incredibly important. The verifier agent is kept entirely separate from the worker agent.
Right.
It doesn't carry over any context from the initial work. It gets a completely wiped, blank slate memory to work with.
2-sec silence. That architectural separation makes a massive amount of sense. It is like having an independent auditor check a company's financials.
Yeah, perfect analogy.
You don't ask the accountant who made the errors to double-check their own math.
You'd never trust that.
Right. You bring in an external reviewer with a clean slate.
Think about a quality control laser on an assembly line. The laser only scans the final car door for dents. It doesn't ask the welding robot how it feels about its job.
Yeah, that makes sense.
It objectively measures the physical product against the blueprints. This matches Finder and Verifier setups across all of AI.
The verifier just objectively looks at the final output. The context window isn't cluttered with previous failed attempts. But this still raises an interesting architectural question. Why can't the original worker agent just be told to check its own work?
Because the worker carries the heavy baggage of its past decisions. It naturally assumes its original internal logic is entirely correct.
Because the worker's hidden assumptions would blind it to its own mistakes.
Precisely. You desperately need a fresh pair of digital eyes.
Answer.
So we have this high-quality verification system in place.
Right. We have a worker and a fresh verifier checking it, but doing this sequentially is just far too slow.
Oh, incredibly slow.
Waiting for each step creates a massive operational bottleneck. We need to speed this complex process up significantly. This brings us to a concept called graph engineering.
Yeah, this is the really exciting part.
Let's define graph engineering clearly. It is, splitting independent tasks into separate paths that run at the same time.
This is where the Maestro's IA workflow gets seriously impressive. Each independent task gets its very own branch.
They don't have to wait in a slow line anymore. Let's look closely at the specific demo they ran. They used Claude Code and Ultracode to build this structure.
Just typing /Ultracode and /workflows into the command line.
The primary mission was to research 3 different YouTube channels: OpenAI, Anthropic, and Google DeepMind.
Right.
And they specifically wanted videos published in the last 7 days.
Think about doing this normally. You would wait for the OpenAI research to finish completely, then Anthropic would slowly take its turn.
Right.
But here, 3 separate AI agents spin up and run simultaneously.
Instead of waiting patiently, the system branches out immediately. It is like cooking a massive dinner for a large party. You don't wait for the chicken to finish before chopping carrots.
Exactly.
Akshay Pachar has actually demonstrated very similar subagent splits recently. Paul Hurin also shows how context is isolated to its specific task.
That isolation is the absolute magic of true parallel execution. And the strict verification loop still happens inside each branch.
Okay, so the verifier agents review outputs without talking to the other branches.
Yeah, entirely separately.
Once all branches are finished and verified, things finally merge. Claude Code brings everything into one final comparative PDF report, beat. But managing all these streams seems precarious. Does running these branches at the same time mix up their data?
Not at all. The underlying system walls off the context for each branch entirely. They don't share any memory until the final merge.
Got it. Each branch keeps its context strictly isolated until the final combination.
That strict isolation makes the parallel processing so incredibly reliable. You don't get agents hallucinating details across different companies.
We understand the theory behind this complex structure now.
Yeah.
But what exactly happened when they hit enter on this workflow? What did the real-world execution actually look like?
The initial demo results are honestly pretty mind-blowing. It was incredibly fast.
How fast?
Each research session took only about 40 seconds to finish and used roughly 54,000 tokens to process the information.
That is a truly massive amount of raw data. Processing 54,000 tokens is roughly equivalent to reading a short novel.
Yeah.
And the system processed that in under a minute.
Whoa, imagine scaling to 1 billion queries. The sheer volume of automated processing is completely staggering.
2-sec silence. Let's talk about the verification mechanics in action. What exactly did these independent verifier agents catch?
They caught some very critical timeline errors immediately. None of the 5 initial videos were actually published recently.
We know them.
Nope. They fell way outside the strict 7-day window.
So the initial worker agents just completely hallucinated the publication dates.
Exactly. Language models are notoriously bad at strictly tracking chronological time.
Right.
But the fresh verifiers caught that instantly. They also flagged a highly specific Google DeepMind video. It could not be confirmed on the official channel at all.
So the verification loop actively stopped bad data, but they also confirmed plenty of good data during this.
Oh, absolutely. The verifier agents confirmed 6 videos with 0 discrepancies whatsoever. It really showcases the rigorous nature of this setup. They validate the good data while catching the subtle errors, all clearly displayed in the final PDF.
There is almost always a hidden catch with these powerful systems. I have to note the very real operational trade-off here.
Yeah, the costs.
Adding separate workers and verifiers burns through tokens incredibly fast.
Right.
You are essentially paying for 3 or 4 API calls instead of 1.
It is definitively a much more expensive way to operate. For an enterprise company, that token cost is a rounding error. But for an individual developer, it really adds up.
Which brings up a very practical concern. With such high token usage, is this setup actually practical for everyday tasks?
It is strictly for large tasks where accuracy is completely non-negotiable. You wouldn't use this heavy framework to draft a casual email.
More tokens mean higher costs, but you get guaranteed quality in return.
That is the ultimate trade-off you have to weigh. You are buying structural peace of mind.
Let's step back for a moment and summarize the core lesson. Let's recap. An AI workflow is vastly stronger when each agent has a clear role. Tasks run in parallel branches, and outputs are checked by an independent verifier with fresh context.
It totally redefines how we should interact with language models. We're moving from being prompt writers to actual system architects. But understanding this does leave me with a slightly provocative thought. If we are building systems where AI independently verifies other AI, What happens when these agents begin writing their own strict grading criteria? Who verifies the verifier when the entire system becomes fully autonomous?
That is a deeply fascinating problem for the very near future. Thank you for taking this deep dive with us today. We highly encourage you to experiment with workflow branching yourself. Stop tweaking the exact same basic prompt over and over, build a strict harness, add a clean verifier, and run it all in parallel. Out to your own music.